presentation. It's very apt that you mentioned Industry 4.0 and the digitization pieces and so forth. And really the theme is AI and data center and also the end user experience. Now one of the core pieces that we miss out in all of this is what does the end user think? And from that perspective, we have our next discussion here that's fine-tuning small language models with knowledge graphs for enhanced industrial insights by Anup, Dubey and Santh. I may welcome them both here, and it'll be nice to hear from the user itself. Thank you very much. Over to you.
Good afternoon, everyone. I'm Anup Dubey. He is my colleague Santh. We are both from Aditya Birla Group. Just a quick intro. At Aditya Birla Group, we are part of Group Data and Analytics team. I personally lead supply chain platform and development of generative AI capabilities. And Santh here leads the industrial analytics use case. So that's why we thought, why not, we work together in bringing these capabilities, knowledge graph, and small language models capabilities into industrial insights. And we have worked on certain use cases. It's a journey like was mentioned in the previous presentation. So we thought we'll take you through the journey that we have gone through. Okay, so we'll start with, these are the contents, why this topic matters, what are SLMs and graphs. I think everyone knows here. What are the industrial insight use cases we have worked upon, how it works, what kind of business value, and what are the future possibilities. So why does it matter? We all know in the industrial space we have different kinds of sectors, different kinds of operating machines, different kinds of processes, and that generates a lot of data. And all of these data are sitting in some silos, which don't talk to each other. The contextual understanding of these data are also not very clear. Now this is very important because unless the data start to talk to each other, you cannot make, bring insights out of them or start to correlate them and or go into deeper contextual understanding. Now even if you have done that, your analytical tools do not, treat those things as structured data, numerical data. They don't really get into understanding what the numerical value mean, and that's where LLMs and SLMs becomes very powerful. We'll take you through how we have tried it. But again, LLMs are big language models, large language models, tend to hallucinate. Grounding them is difficult, and that's why we pivoted to small language models while leveraging the capability of large language models in development of knowledge graphs. That's a critical point over here. So SLMs, again, compact, fine-tuned models. They can be used for any specific use cases. You can create SLMs for your procurement use case, for financial use case, for financial use case, for manufacturing use cases, which Santh will take you through it, and it's cost-effective and faster. Knowledge graphs, again, it brings relationships and understandings between entities. Now, for example, if I take you to a library and you start to go around, it's a vast thing, right? You will want to know where the mathematics section is. Between mathematics, it is under algebra. Algebra drives some other, areas of maths. So that understanding is what is very critical into traversing your data faster, and also bring the right data to the context and for the training. So that's where knowledge graph becomes very, very important. It brings relationships, grounds it, doesn't allow your SLMs to, hallucinate. And again, the data on which it is to be trained also, it gets very, very specific to the data that you want on your SLMs to be trained on. So quick thing, the point here is LLMs are for, what we have tried upon is LLMs for creating all this knowledge graph construct, and SLMs for fine-tuning the data. This is the, vast data that we have. The SLMs, the knowledge graph extracts the relevant data, trains the data, and then again that graph construct is used for user querying. When the user queries your large amount of data, it still needs that original graph that was created to bring out the relevant insights and answers. I'll hand over to Santh to walk you through certain industrial use cases he has worked upon in that same concept.
Thanks, Anup. So much heavy words, right? So So let's take it lightly. LLMs are large language models. Basically, they have a lot of knowledge, but they don't know the specific knowledge. You understand about the generalist and the specialist, right? So if you ask a generalist about the very specific industry specific your use case or your knowledge, then he will not be able to understand. So how you breeze that? You go to a specialist and ask him to get the specific knowledge, right, or insight from it. So what we do here is, I'll take you through one of the example. It's not exactly the example, it's an example. It's not exactly the use case or example from or the scenario what our industry is working on or worked on, because there are some confidentiality issues. So we take some example, extracted some information so that it can be relevant to help you understand it. For example, let's say maintenance intelligence for AI, we say. So what you say is, why did my kiln specific heat consumption spike yesterday? This is the questions your leadership or a lot of CXOs, plant heads do ask every day, and they have a challenge in that. Why did my support roller bearing failed in the kiln, or any breakdown happened? These are the questions being asked a lot of time. What we do is, to understand that you need a lot of data. Data means where I need to extract the data, what data I need, that also we don't know. So a lot of time experts also face challenges that what data I need to get to understand that analysis has to be done. So what happens is we have a data, structured data, SAP data, LIMS data, LIMS quality data. Then you have a time series data, that is historian, you have a lot of data. Then unstructured data, operational manuals, maintenance manual, post breakdown, RCAs, historical post breakdown RCAs, operator logs. Though usually people analyze all those structured data, means like time series data or structured data. But how do we leverage this operational maintenance manuals? How do we leverage this unstructured data which is having the operator logs? Maybe post breakdown, somebody has posted that past breakdown RCAs in some of the plant, but we don't know how to leverage that. So what we do is, these SLMs extract that data from specific sources and give you an insight of, and it gives a deep dive analysis supporting with the references, why he is doing that or why he is giving that insight from that data, or reasoning, why he is giving that reasoning. That reference also he gives, because somewhere this kind of breakdown happened in the past. He references that and give you that support that your confidence level will be increased because of that. What it uses the asset taxonomy, it uses the graph construct. There are multiple graph constructs actually. How Anup explained, like we have a graph construct to be built on different data set, which is called a knowledge graph. How it works, that's maybe you will be looking for it, how it works. So you start with a data ingestion, historian, MES, ERP, a lot of data you have to collect. So you create a data lake kind of, don't worry about where the data stores, but you need a data. So now this data has to be a qualitative data. So data quality check has to be there somewhere. Now you start with a graph construct. Means like I have a data. Now you need to, graph construct is something that you have some of the information with the graph construct that this data is related to something else. You go to like library you are saying, you are going deep and deep and deep, then where you will land it. For example, you are producing clinker, then your clinker production process has a graph, like kiln asset is linked to a fuel of coal and linked to a maybe limestone quality, linked to the operator engaged in a particular shift. All those are graph constructs, that they are interrelated. Now, then you select those data and you select a particular kind of small language model, not large language model, a generic small language model. Take it from the market, don't build on your own because it's a very costly factor. So take that maybe 5.3 gamma or something, you can take that and you tune that based on your operational knowledge of your factory. Now your data is yours, knowledge is yours, it is tuned to cement manufacturing process now. It is very specialized basically to your cement manufacturing process, specialized for your steel manufacturing process, specialized for your oil and gas process. It can be a finance analyst also can be built similar way. when you take the data and ask the model to be analyze multiple kind of how the finance data to be seen, how EBITDA has to be calculated, how other finance data has to be looked at, how GRN is being processed. If you feed that knowledge to this SLM, it becomes specialized on your industry specific or business specific data. Now, the real time what happens is we extract the data, which is called RAG automation or retrieval augmented generative system, and we embed that into a graph construct, and that happens. I'll show you a very kind of example. Like, we always talk about large language model, LLM, AI, but when you see specific tasks, these small language models work beyond expectation than the large language models. This is the high level architecture. You should look at it. If you want to take a picture, you can take a picture. This is your data layer, which is called unstructured data, structured data. Structured data I explained, like, which is called as a table kind of thing. That's a structured data. Unstructured data, you do it indexing, chunking, vectorization, and store in a way. So there is a process to how you extract the unstructured data and store it. Then you have a knowledge graph. I explained how knowledge graph can be built. That's the knowledge base of your industry. Now you have some of the SLM trained, which is called domain expert, we call. The user queries and you activate a master agent. This can be LLM or SLM. That's okay. Now the master agent engages a data collection agent. He knows which data has to be collected. Where he gets that knowledge? He gets that knowledge from the knowledge graph. From the knowledge graph, he knows that what data I need to analyze it. So he gets those data, specific data from your database, puts it in the graph DB. Graph DB because it is very easy for now the SLMs to analyze those data because that's processed better in a natural language way. So these domain experts are engaged parallelly along with the graph database, and it gives the user the required information or answer, which is user has to consume in a way he can consume, along with the references, where he got that inferences, why he got that inferences, why he is telling that this has to be like this. So what business value you will get? Usually it supports the decision making, leverage the power of LLM, creating the multi-process functional business specific graph assets. So we are leveraging LLM for specific to generating knowledge graph once. After that, we are leveraging the SLMs to fine tuning to create it a business specific expert, and doing that this technical aspect or creating the technical capability, we are achieving time to insight reduced to almost 80%. I think most of the leadership assistants will be working an entire day to analyze their answers and coming up in the evening answering that how and what happened. And you can understand that how industries are moving fast and decisions are has to be made fast and with an accurate manner. If you do not support why it has happened, why I need to take this recommendation, not only it gives the answers, it also recommends sometimes. If you ask, it can recommend sometimes what has to be done, what the leadership should do to betterment or overcome that challenge. So it supports the decision, but it cannot take the decision. We should not let AI at this stage to take decisions. It has to be human in loop. It can support human with their recommendations, and human can take better decision with informed way. That's the thing we are trying to explain here. The important thing is the trust and traceability. When you ask a LLM going through and it gives you the recommendation or information or causes, it doesn't say that why he is saying this. So this traceability, and this traceability is coming from your own data, that gives you a confidence that why I should take this decision. That's the kind of trust and traceability improves so much. Future possibility, we are looking for scaling for different domains coming out of, not only in the manufacturing or finance domain, we are looking for healthcare domain, maybe fiber domain, we are looking for that. high risk decision makings are done in a daily, day for purchasing purpose, for forecasting, trading purpose. Some of the decisions are getting being taken. So we are trying out or looking out in that aspect, but it's not yet gone so far. So integrating agents, we are looking for an automated way how multiple agents can work for retrieving the data, and it can work autonomously and giving a complete report per day. And some agents we are thinking of to leveraging take automated action, but with a human approval. Then we also are looking for embedding SLMs in edge device so that faster actions can be taken, because now it's working on the cloud, data has to come to cloud, you need a data lake, you need a lot of infrastructure. Now we're looking for how it can be made more smaller and it can be given to the plant locations for edge computing or edge kind of capability. Yeah, that's all. I come to most of end of the session. So what are the takeaway for us is SLM provide the agility and specificity. Knowledge graph gives the structure and context, and together they help industries move data driven to insight driven. Now we are working on mostly data driven, right? We call it as we have a data, we need to analyze it. But who will analyze it? Now this thing will give you a better analysis. So this is insight driven business we can do. So happy, I'm open to.
Just one point I wanted to add. The architecture that was shown, think of it like a car. You have a driving wheel, you have engine, you have tires, and each of these has gone into its own innovation cycle as to how do we optimize each of them, how do we optimize a graph construct, how do we set up our master agent. It's just master agent written here, but master agent performs a lot more role than just passing it to a data collection. It analyzes user input to make sure, understand that what user is asking is actually what user wants. Sometimes user just writes generic string. So how do you go into that thought process? So all of thinking capabilities we have tried to implement. So each of these has been a small innovation cycle that we have gone for each of these components that is listed out here.
So here itself is a loop thing. It's until unless after master agent is satisfied that user has given me enough information, I need to answer. Till then he will not proceed. He will wait, ask follow-up questions to the user. So amplifier it's a complex, we can go deep dive, we have a limited time, so we come to this option. Thank you.
Anup, Santh, thank you very much for this very insightful presentation. And folks, just to let you know, they did this on our very special request within, I think, a time of a few hours. So, not just that they're good at making master agents, but they themselves are master agents as well.